Hi, everyone. Welcome to section 3.2. In this section, we are going to be discussing exponential functions, and we are going to explain how to graph and how to evaluate these types of exponential functions. So previously, we've talked about polynomials. So polynomials look at the form as x squared, y equal x squared, y equal x to the cube minus 1. Now we're going to look at this exponential, which is y equal 2 to the x or y equal 3 to the x minus 1, where now x is going to be the exponent and 2 will be the base. Here 3 is the base and x minus 1 will be the exponent. So let's begin by defining an exponential function. Let b be a constant real number such that the base is greater than 0 and the base is not equal to 1. Then for any real number x, a function of the form f of x is equal to b to the x is called an exponential function of base b. So what we're interested in first is to graph the functions. In order for us to graph this function, we need to notice that this function is exponential and x is called the independent function. X is independent. So I'm going to be able to substitute values for x. So what I'm going to do is I'm going to pick -2, -1, 0, 1, 2, 3, and 4. Now I want to see what happens to the left of the x and the positive. When I plug in -2, what's 3 to the -2? That's the same as 1 over 3 to the positive 2, which is 1 over 9. Now, whenever I have a negative exponent, so one of the rules for exponential functions is when you have b to the -1 power, it becomes 1 over b to the first power. Now here, if I have remember where the base, in this example, the base is equal to 3, and the exponent is x. So then I have 3 to the -1, or 1 over 3. Now 3 to the 0 is 1. 3 to the first power is 3. 3 squared is 9. 3 to the 3 is 27. And 3 to the fourth is 81. You can also use your calculator to check. 3 times 3 times 3 will be 27. 27 times 3 would be 81. Now our interest is in graphing, so let's go ahead and begin by graphing the point -2 comma 1/9. So that's -2 1/9 is very close to 0. -1 comma 1/3. And then again, I'm zooming in a little bit. I'm going to go zoom in a little. So -2 1/9, and then right here, and then at 0, I'm 1. At 1, I'm 3. At 2, I'm 9. At 3, I'm going to be 27 up here. And then at 4, I'm going to be 81, all the way over here. So then the graph of the function looks like this. This is called an exponential function. So this graph right here corresponds to 3 to the x. Y equal 3 to the x. That's the function. Now, what happens if we have 2 to the -x? Again, we're going to substitute -2, -1, 0, 1, 2, 3, and 4. X is our independent function, so we're going to be substituting. We have f of -2 is going to be 2 to the -2. That gives you 2 to the +2, which is 4. Now, f of -1 is going to be 2 to the -1, which is 2 to the first power, or 2. Now, f of 0 is 2 to the -0, which is 2 to the 0, or 1. You can also have 2 to the -1 because you're substituting 1 into f. So let me go back here. F of 1 is 2 to the -1, which is 2 to the -1, or 1/2. when I find f of 2, 2 to the negative 2, or 1 over 2 squared, which is 1/4. Remember, you do have the capacity on your calculator to substitute the functions in graphs, so I'm going to show you how to do that too. I'm going to substitute, and I'm going to have 1/4 f of 3, 2 to the negative 3, because I'm substituting 3, 1 over 2 to the third, or 1 over 8. And lastly, f of 4 is 2 to the negative 4. So it's 1 over 2 to the fourth, which is 1 over 16. Now I'm going to go ahead and graph -2 and 4, -1 and 2, 0, 1, 1, 1/2, so half of that, and then 2 and 1/4, and then 1/8, and then 1/16. See how it's decreasing? So then my graph will look like this. So this graph is y equal 2 to the negative x. See how the order changed now? Instead of increasing, I'm decreasing. I'm decreasing. I'm approaching 0. Instead of approaching infinity, I'm approaching 0. Now, what's the difference on question 3? Well, question 3, you have a number over here, and then you have a base with a minus in front. And you can go ahead and use what we just learned and then evaluate some numbers. Recall that when you are working with an exponential function, we can also use the information about transformations and shiftings and all that good stuff that we learned before. So what we're going to use is we have different things. We are going to be substituting. So if we go back, if we have our function, so notice that this looks like 2 to the x. I have a 2 to the x. I know how the graph of that looks like, kind of. I'm going to add a 1, and then I'm going to add the value 1 to it. So I'm going to be, again, choosing independent values for x. I want to look for independent values, so I'm going to pick -3, -2, -1, 0, 1, 2, and 3. That way I know what's going on at the left side and at the right side of my exponential function. Now let's go ahead and substitute f of -3. 1 minus 2 to -3 plus 1. 1 minus 2 to the -2. 1 minus 1 over 2 squared, or 1 minus 1/4, which is going to give you 3/4. Now f of -2, you get 1 minus 2 to the -2 plus 1, 1 minus 2 to the -1, or 1 minus 1/2. And I get positive 1/2. F of -1, you get 1 minus 2 to the -1 plus 1. You get 1 minus 2 to the 0, or 1 minus 1, because 2 to the 0 is 1. And I get 0. And then f of 1, so here, I'm going to plug in 0. F of 0 is 1 minus 2 to the 0 plus 1. I get 1 minus 2 to the first power, or 1 minus 2, or it's -1. F of 1 is going to be 1 minus 2, 1 plus 1, which is 1 minus 2 squared, or -3. F of 2 is 1 minus 2 to the 2 plus 1, 1 minus 2 to the third, or 1 minus 8 is -7. And then 1 minus 2 to the 3 plus 1, which is 1 minus 16, or -15. Now I have all of my points, and I'm going to go ahead and start by graphing. So first I'm going to have -3 3/4, -2 1/2. So 1/2 is less than 3/4. At -1, I'm going to have 0. -1, I'm going to have 0. At 0, I'll have -1. At 1, I will have -3. At 2, I will have -7. And then at 3, +3, -15. So all the way over here. So that means it's going to shift like this. So this graph right here is exactly y equal 1 minus 2x plus 1. Another way you can look at it is using transformations. So now let us use transformations. And we begin with the parent function. So I'm going to use scratch work here. And within that scratch work, I began with graphing y equal 2 to the x. Well, if I recall, y equal 2 to the x, it looks like this exponential function, right? Because if I have x and y, if I have -1, 0, and 1, 2 to the -1 is 1/2, to the 0 is 1, and this one's 2. So I have -1, it's a half, 0, 1, and 1, and 2. So that's 1/2, 1, and 2. So it's going to be increasing. Now I have a negative in there. So because instead of having y equal to the 2x, I have y equal -2 to the x. This means that you are going to reflect across the x-axis. So then because of the negative, it automatically reflects it this way as y equal y equal -2x. And lastly, you have a shift +1. So I'm going to take this whole thing and bring it up 1 unit. So then here, I'm going to bring it 1 unit up. So basically what I did is I shift every y value up 1 unit. And what am I doing? Well, because k is 1, then you shift upward. So, and that's exactly what we have right here. So the original 2x, right? You have 1 at 2 and then 4. So this behavior is 2 to the x. But you have a reflection across the x-axis because of the negative, and then upward 1 unit because of the +1. So what I'm going to do now is I'm going to project my calculator. So I'm going to go to calculate 84. That way you guys are able to see this as well. And then when you are working on the exam, then you know what to do. And then check your answers, of course. So there's my graphing calculator. I'm going to go into y equals. I'm going to erase everything, and I'll start by graphing the first equation, which is y equal 3 to the x. So that's this little hat and then x. And then I'm going to select graph. I'm going to zoom um, I'm going to zoom in a little bit. That way you guys have a better picture. So see how it's increasing. Now the next part is due to the -x. So I'm going to go back to y equal, and I'm going to erase it, and I'm going to put 2 raised to the -x, and then hit graph. See how now it's decreasing as I'm zooming in. Now it's staring down. I'll get the orientation. And I'm going to then, lastly, I'm going to graph y equal 1 minus 2 raised to the parentheses x plus 1. So then I'm going to hit graph. So see how there's a shift right there. I'm going to hit y equal, and I'm going to go to the second graph, which is 2 raised to the x. And then let's look at the differences. So first of all, the reflection, the adding plus 1, and then there was a horizontal shift because of the exponent of x plus 1. So note that within that question, this x plus 1 on the inside of a function, this x plus 1 in the inside of the function means horizontal shift. So you also had a horizontal shift. So using transformations, we started with y equal 2 to the x. It shifted across, it reflected across the x. It shifted upward, and then it also shifted to the right. Excuse me, it's going to shift because it's a plus 1, it's going to go to the left 1 unit. So don't forget the shift. So make sure you have this down. So the A stands for the reflection. If we have any reflections, K up or down, and H to the right or to the left. Now, for the following, we are going to be using our calculators to evaluate. So let's define the value E. E is an exponential function, an exponential value with a base E. E is a universal constant. It's like a value of pi that's like it keeps on going. So as x approaches infinity of the formula 1 plus 1 over x to the x, it approaches the value E. So what we're trying to do is just evaluate. I'm not going to be asking you to do it by hand. So for questions 4 through 7, take a moment and go to your calculator and substitute the value. So I'm going to clear it. And then right here, you're able to see the E right below ln. So you're going to go to second E, and then the first question is squared. So raise it to the square, and it's saying you want 4 decimal places. So that's going to be in the solution 7.38905, but you round to 4 decimals, so it's 7.3891. So you want to make sure you're respecting that round off rule, 4 decimal places. The next question is e to the negative 3. So I'm going to go to second ln, and then I'm going to put parentheses, and I'm put a minus 3, and then I'm going to close the parentheses, and then select enter. And that's going to be 0.04978, but I want 4 decimals, so it's 0.0498. And then let's look at the next question, second ln, and then parentheses, second square root of 7, close the square root, and so you want to make sure you're using parentheses to evaluate, and see how there's a syntax error. So let's try that again. Second E, let me remove all this. So it's going to be second E, and parentheses, second square root of 7, move it, and then close the square root, and then there it is. So the answer is going to be 14.09403, but I'm rounding to 4 decimal places, 0.0940. So rounding to 4 decimal places, and last but not least, e to the pi. So second E, and then pi is right here where the caret is, second pi. Hit enter, and you should get 23.14069. And then rounding to 4 decimal places would be 23.1407. So looking at all the solutions that we just did using our calculators, there they are. So I put in the value and then I rounded to 4 decimal places as I wanted it. So we want to know how the graph of 8 looks like. And then we're going to be doing some application problems, and that's going to be the end of section 3.2. Alrighty, so let's go ahead and graph this exponential function. And remember, we want to notice that x is independent. So I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. And then we can go ahead and evaluate this using our calculator. So f of -3 will be e to the -3 plus 1, which is e to the -2, or 1 over e squared. And we are going to be using our calculator for all of these values. And then it's going to be, so this is 1 over e squared. I'm going to be approximating the answer. F of -2 will be e to the -2 plus 1. It's e to the -1, 1 over e. I'm going to approximate it. I'm going to use my calculator. F of -1 is going to be e to the -1 plus 1. That's e to the 0, or 1. At 0, f of 1 will be e to the 0 plus 1, or e to the first power, or just e, which is approximated by the value 2.718. 2.718. And then, sorry, this should be f of 0. And then f of 1 is going to be e to the 1 plus 1, or e squared. E squared, and we're going to be approximating them. So we're going to be finding what those answers are. We're going to be approximating, but I'm giving you guys the exact. And then f of 2 is e squared plus 1, or e to the third. And then f of 3 is e to the 3 plus 1, or e to the fourth. So e cubed, e to the fourth. So what we can do is we can use the parent function, y equal e to the x, and then shift. Because if it's a plus 1 on the inside, it's going to be a horizontal shift to the left. So we're going to shift horizontally 1 unit to the left. Or we can graph the points. So we begin by going to our calculator again. And I'm going to hit y equal. I'm going to erase everything. And then I'm going to graph both equations, the parent function, which is e raised to the x, e to the x. And then I have e raised to the parentheses x plus 1. And then I'm going to plot both of those and then see you're shifting to, so if you go back, and the blue one is the original function. So this is e to the x, and then I'm going to shift everything to the left. So you shift e to the x plus 1, 1 unit to the left. So going to my iPad here, I have e to the x, and then I'm going to shift to the left 1 unit because it's e to the x plus 1. So it's 1 horizontal value. So I can go ahead and identify what's 1 over e squared. So if I do e raised to the square, it's going to be 1 over that value. And then that's approximately 0.135. And then 1 over e, it's 0.367. And then I have just 1. And then I have e, which is 2.7. It's 2.1, 2.718. And then e squared it's going to be 7.389. And then E cubed is 20, roughly 20.085. And then e to the fourth is going to be 54, roughly 54.59. So right now, this is a really rough sketch here, but with the values, we identify the parent function, and then we can see that it shifts horizontally to the left 1 unit. Alrighty, let's look at the next part, which is using exponential functions to compute compound interest. So when we're dealing with exponential functions, there's a good use for them, and we see them in application problems that involve compound interest. So there's three different formulas. The first formula is called the simple interest I in dollars, where P is the principal amount or the amount invested at an annual interest rate R for 2 years. Then the simple interest rate is I equal PRT. Now we have a compound after different periods of time. So instead of once a year, it's twice or 3 times, or compounded during different parts. So amount A in dollars is the account after T years, and N is the compound. So you have this is P, this is the rate, and this N is called the compound. So how many times it's generating at a period amount. And then you have a continuous compound. That means it's ongoing, compounding continuously, and that makes it PE to the RT, which is an exponential function. So what we're going to do for number 9 is we are going to be applying the following formulas. So again, this would be for a simple interest once a year. So it's one time a year. And then we have this compound for a certain amount, a period of time. So when N is 1, that would be annually. When N is equal to 4, that's quarterly. When N is equal to 12, that means monthly. When N is equal to 2 is semi-annually. So, and then daily, of course, if it's compounded daily, N would be 365 if daily. If it's compounded daily, N would be 365 if N is equal to 1 annually. If N equal 4 quarterly, N is equal to 12. That would be a monthly interest. And then N equal 12, N equal 2 would be a semi-annually. So these are the different types that you guys can identify when you're doing your homework for compound interest periods of time.